This lesson is on trig ratios, and something that we need to always be mindful of, and so this is something you've not learned before, so this is all brand new. Trig ratios are for right triangles or right angle triangles. So remember, a right angle triangle will always have a hypotenuse. Right angle means you've got 90 degrees. So we're going to look first at the right-hand side of our page, and we are going to label the sides of the triangle based on or with respect to the angle that we're concerned with. So here I've marked the angle with the Greek letter theta. That's a very common symbol that is used for angles. So here in the trig section, you're going to come across a few Greek letters. And so the first side we're actually going to label is the hypotenuse. And the hypotenuse is always the side opposite the right angle, and that's very important. And then we are going to label the other two sides, or the legs of my triangle, with respect to theta. So this side here is the opposite, and we have the adjacent. And so the rule for sine is sine of theta is opposite over adjacent. Now let's look at cosine. So we're going to label the sides first. And then we have the opposite to our theta, remember, and the adjacent to theta. And the rule for cosine is that cosine of theta is equal to adjacent over hypotenuse. Right, now the last trig ratio we're going to look at is tan. So we label the hypotenuse, and then we know we have our opposite, and we have our adjacent. And then the rule for tan is tan of theta is opposite over adjacent. So now I'm going to bring you back up to this wonderful word here. It's actually an acronym, SOHCAHTOA. And SOHCAHTOA is a way we can remember our trig definitions. So you will see here, this is sine equals opposite over hypotenuse. And then we have cosine. So cos is adjacent over hypotenuse. And then our last one, tan is opposite over adjacent. So now we can break down the steps to solving for a side, or how do I use this knowledge of trig ratios? Well, clearly we're going to use it to find missing side lengths. We could also use it to find missing angles. So the step first is we're going to choose a trig ratio based on labeling our lengths, so our known lengths and what we're looking for. Then we're going to write an equation that uses that ratio and whatever we're looking for, and we're going to solve. So let's see what happens. So in this first one, it says label the sides in relation to the given angle, then choose a trig ratio to find the length of the hypotenuse. And I've actually labeled my hypotenuse with the variable. So we know the hypotenuse is k. Here is my angle. So I have the opposite, right? I don't have the adjacent, so I don't want to use the adjacent because this is, I don't know this. And I don't need it because they're asking me for hypotenuse. So I'm not going to use a trig ratio that uses the adjacent. I want a trig ratio that uses the opposite and the hypotenuse. And that trig ratio is sine. So we're going to say sine of 61.2 is equal to the opposite, which is 23.8, over the hypotenuse, which in this case I have called k. And so now we need to solve for k. So I'm going to start you off just in case you need that extra reminder. But this is just, now we are solving a linear equation, right? So what's going to happen? Well, k has to first get multiplied up so it's no longer in the denominator. So we're going to say k equals, sorry, not k equals, we're going to start with k times. Mind you, if you are able to solve in one step, that's fine as well. If you were able to get to here, if you can go straight, if you are able to go straight from here, so you must have that first initial statement, but if you can go from here to here in one step, that's fine. Okay, but if you can't, then you should be showing me that middle step. All right, because if you are getting it wrong consistently and you are not showing me the middle step, that means you need to show me the middle step. And so now I want you to use your calculators and get the answer here. And we will check those answers tomorrow in your groups. You can check with your peers and see what you guys got. All right, so now next one. Label, and I'm labeling it all the time here. If you are, and I like to write my hypotenuse like this, you do not need to do that at all. All right, so hypotenuse. Label the sides in relation to the given angle, find the length. So here is my angle. So this is the adjacent to my angle, and they want the height. And the height, I'm actually going to call it h, but that is the opposite to my angle. Okay. So we have an angle. We have the adjacent to that angle, but we want the opposite to that angle. So which trig ratio uses opposite and adjacent? And that is tan. So we start by writing out the equation with that trig ratio. So tan of 29.5 is equal to opposite, which I have labeled h, over adjacent, which is given as 18.2. Oops, 18.2 times 10 of 29.5. And then again, your calculator will give you an answer, and we will check this tomorrow in class. You will check with your group. And remember, in a question that gives us units, we have to give units back. So if we look here, the first question gave us units of meters. So we, in our final answer, will have to have meters. Here as well, we were given meters, so we must give meters as well. All right, so before we do the next example, I want to tell you about inverse ratios. So these are trig ratios. They're also trig functions. So sine has an inverse, and our inverses are used to find the angle. So in this case, I'm just going to call my angle theta. And inverse sine of opposite over hypotenuse will give me theta. Likewise, inverse cos of adjacent over hypotenuse will also give me theta. And then inverse tan of opposite over adjacent will give me theta. So that is how we find a missing angle. So here with our missing angle, we are given the hypotenuse. This is the opposite to my angle. This is the adjacent to my angle. I don't know my angle though, but I know the adjacent and I know the hypotenuse. So the trig ratio that uses these is cosine. So I'm going to say cos of theta is equal to the adjacent, which is 6, over the hypotenuse, which is 9. So in order to solve for theta, theta is inverse cos of 6 over 9. And this is important. Inverse cos is not cos to the power negative 1, because cosine is a function. It's not a number. So you will notice on your calculator, above the cosine button, above the sine button, above the tan button, you will see, like above sine, it says sine, and then it has negative 1. That's your inverse sine. So it's basically your second function for that key. So you are going to have to work out second function. So inverse cos of 6 over 9. And here, you're not going to give me meters because we're solving for an angle. So here, you are going to have to remember to give me degrees. Okay? So we will check this work, or you will check this work with your peers tomorrow in class. And so before we move on, we're going to look at our reciprocal ratios. So reciprocal ratios, a reciprocal of a fraction is when we flip the fraction over. So it is the same thing, except we actually have names for them. So cosecant is 1 over sine. Secant is 1 over cos. And cotangent is 1 over tan. So in our practice problems tomorrow in class, you will need to use these reciprocals. So that's why I'm giving them to you here. And remember, you need to finish each of these examples, get your answers, don't forget your units, and then we will go over this in class. You will have a chance to work with your groups, check your answers, and then work on your questions in class.